Welcome back again. So we've got kind of a big project to finish things up today. So the goal for today is to make a two-player game. And so the idea of this two-player game is it's called Speed Grab. If you watch the original Scratch Day 1, they made this game. So they made Speed Grab. And it's a little bit more complex to make in Python. But the idea is that there's two players here, so I'm just kind of showing Scratch. The one player is WASD, and so they're the octopus. And so the octopus is trying to get to the fish first, and so that's kind of the goal. And then the other player is the up, down, left, and right arrows, and they're trying to get to the fish as well. And the winner is whoever gets to 10 first, so they're the sharks one. So we're going to be building this game in Scratch, just to kind of like reiterate those skills and kind of learning things. And then, of course, the big thing is we're going to be running it in Python. Now, you can continue to use REPL. So, I mean, that's kind of what this camp is designed around. But I will say that we are definitely like pushing the limits of REPL's like speed performance, right? So you can see that we're kind of like lagging along. So I do still want to do it. Maybe this will be the time when you're sufficiently motivated to run locally on a computer. I think that I will go ahead and put a video together about how to set it up locally on your computer. I'll go ahead and run it locally here as well. So this is the exact same code. It's just running locally on my computer. And you can just see how much better the performance is. With my video, it's kind of going laggy here. I made them kind of small because I think that makes the game more fun, but you can see that the shark can go around and grab them. So the lagginess has nothing to do with Python and everything to do with online IDEs. You can kind of see why online IDEs are good and easy to get going, but they do eventually run into this performance issue. And I think today is the day where we've jumped the shark, so to speak, as far as performance issues. So let's go ahead and get started. So we'll go to Scratch and we'll create a new project. And this is going to be called Speed Grab. Speed Grab. It is just a scooch different than what they did on day 1 of the Scratch camp. So if you want to remake it today, even if you've already done that, it's not too hard to remake. First things first is I want to get my different sprites in here. So for me, I'm going to choose to use a shark and an octopus. You can use whatever you want, right? So it doesn't matter. You need essentially two character sprites. So it's the shark and the octopus. And then you also need a target. And if you want to use images from the internet, you totally can. If you want to use images from the library, you can totally do that too. I think that I will go ahead and put on an oceany background. You can adjust sizes to you see fit. They're definitely way too big. I would make them some amount smaller. I think roughly 50% is better. There are the octopus. I think I did 60, 50 on the fish as well. Cool. Now, if you wanted to, you could go ahead and like work a little bit more in parallel. Maybe we should try that. Maybe that'd be fun between Python and Scratch, because we've got all our images set up right now. I'll tell you what, just for giggles, let's try it. I don't know if this is going to be good, bad, or terrible. Good, bad, or terrible. We'll see. Let's go ahead and start the Python project. And we want to make sure that we do the Pygame one. So Pygame replit. And this is going to be called Speed Grab. And we'll go ahead and just kind of do things a little bit at a time. Now, one thing that I do regularly do is I do copy code from previous days. And so you might need to pause the video to do this, but I like to copy from some previous day. So here's the airplane that we did yesterday. And I don't need to copy like a whole bunch, but it saves me time for something. So maybe I'll keep one example of making text and making a message, and then I'll comment out these for now. So this is my forever loop. I'll probably need a forever loop. So just having this is kind of enough to help me get started today, so I don't have to like type this again. If you can find an old project and you can copy it, do just like I did. But of course, if you can't find anything, then you could just type it. So this is going to say shark 0, octopus 0 for now. Cool, let's go ahead and get some of those images. So getting the images is something we've done many times before. We're just going to steal them from out of Scratch here. I think I like that octopus better. Before you export an image from Scratch, make sure you do this convert to bitmap, and then you can say export, and we'll go ahead and export these things. So I want an octopus. You can see the shark has two options, a hammerhead or a normal shark. I think I'll just go with the normal shark. And then a shark. The fish, by the way, we always have this problem where white becomes transparent, if you remember that. So what I'm going to do is I'm going to do something sneaky before I go over. I'm going to actually change these colors to kind of like something that's not quite white, right? So this is like nearly white, but not quite white. And I'm going to change these white things to be that not quite white. So there's no way you could have even seen that change, but these used to be white and now they're nearly white. Does that make sense? I guess there's a couple in the fins here too. And so I changed each of them using this fill tool and setting it to a slightly not quite white color. And I did that for the back tail, this middle section, this thing, and then up here. Very subtle. Convert to bitmap, and then export. I'm just going to call this my fish. And so now I'm starting to get some of these images. I've got my fish, my shark, my octopus, and then the last thing I'm going to need is my backdrop. So I'll convert it to bitmap as well. I did that just extremely fast because you can pause the video, and it's also the exact same task we've done in the past. So Scratch has this advantage of having a built-in image editor, which is cool, but it's just easier to get the images from there. Replit has the problem of will take forever the first time we run this program, so I'm going to go ahead and hit run here, go do some stuff in Scratch, and then come back. But I went ahead and got my images all brought over now, and now I can do a couple things in Scratch. So I hit run over here just so it'll start doing its little import thing, and then we'll come back and write some code over here. Could not connect to server. That's no good. What if I hit refresh? Hope I didn't lose anything. Try again. All right, project save there. All right, so let's go write some code on this. So the first thing we want to do is we want the shark to start in this position. So we're going to say when green flag clicked, go to that XY. We want the octopus to start in this position. So we're going to say when green flag clicked, go to XY. So I just kind of want everybody to start when a new game is right where they're at. And we'll go and do the fish as well. So when green flag clicked, we'll position him right where we want. We'll say go to this XY. There it is. Cool. And so now even if you move people to weird spots, when you hit the green flag, they'll snap back to where they're supposed to start. All right, so we'll start writing code with the octopus. We'll go over and check in on this. So he's still working on resolving dependency. So the octopus, we want to be able to move with the up, down, left, right keys. So his goal is that he's going to forever be listening for 4 keys. So I'm going to have 4 if statements here. You can drag over 4. I did a duplicate trick there. And so he's going to be listening for the different keys. He's going to be listening for key up, key down, key left, and then also key right. So he's going to be listening for up, down, left, and right. When those things happen, he's going to change his X for the left and right arrows. So the arrows left and right is going to be changing the X. and then he's going to be changing the Y for the other ones. Change Y, change Y. Of course, up is positive and down is negative. Then left is negative, and right is positive. So I'm going to go ahead and run it and see if I can move with left arrow and right arrow. That seems to be working well. And then up and down. And that seems to be working well. Now my Octopus is going to have a lot of the same things. It's just going to use WASD. I could copy the code over now, but I might wait till I finish the Octopus or finish the shark before I copy the code over. Let's go see how this is doing. Hey, it looks like it ran. So that was good. And it says it shows my background, and then it's also got this message on here. So I think that I'm ready to do some more stuff in Python. I kind of want to get my screen to where it looks pretty. There you go, that looks pretty. If I wanted to catch Python up to what we've done so far here, I totally could. I guess I'll have to make some variables. So I'll have to make a shark. So he's going to be a new image. And of course he's going to use the shark PNG. And then you can decide where his X and Y's are. I think I'm going to put him somewhere over on the right, and then somewhere towards the bottom. And then his size is going to have to be smaller. I think that what I did is I made him super teeny, like 30% or something like that. Let's see if we can make the others. So we're going to have a shark, an octopus, and a fish. And of course they use different images. And then the octopus, I want him to start over on the left, which I believe is -350. The fish, I'll start in the middle, and I'll start him up higher. So that should add the 3 sprites. So I'm going to go ahead and stop it and run it again. Let's see where they show up. So you can see that I've got an octopus, I've got a shark who's just kind of sort of barely off the screen, but that's okay. And then I've got a fish up here. So octopus kind of starts off the screen, not worried about it, right? Cool, so we got those things going. Now the code that we have over here checks for the octopus up, down, left, and right, so the shark, and moves him, which is kind of neat. Let's see if we can do that. Why not? So I copied this code from my airplane project. So my airplane project had kind of stuff that happened in the forever loop. Notice that there's one forever loop that all code shares that's more traditional than what Scratch does in programming. And so we've got this repeat forever loop. And really what we want to do is we want to see if a key is pressed. And so again, you can go look up in the documentation about how this works, but it's a special function, play dot. That means we're using the play library. And the function is called key is pressed. And so I was hoping that it would autocomplete for me here. There it goes, key is pressed. And so it's got an example here. So play dot key is pressed, up, comma, W. So this would actually listen for up or W's, which is kind of a neat thing, so you can pass in multiple. Really what I want is I want up. And then just because I like to test things, I like to actually just say you pressed up. And so if I run it again now, if I press the up arrow, it should actually print you pressed up. I don't see where it prints out anything. So I'm not happy with that. Let me stop it and try again. So let me copy that and do W and say you press W. Sometimes the up key is a little bit weird, but the others should be fine. There you go. So you press W. Oh, and then there it's running fine. So not quite sure what was going on before, but I've got up and I've got W. So we're going to want to listen to a bunch of keys, and instead of actually saying the words up, I just want to take the shark's Y and make it equal to whatever the shark's Y was before, and up is positive, so I'll say plus 10. You might have to play with the speed some a little bit. And then W is going to be for the octopus. So if I stop it and run it again now, the up arrow should make the shark go up. Oh, I know what it is. I've got to click in this window maybe. Yeah, so I've got to click in this window. So the reason mine wasn't working before, and you might have this, is because there has to be focus like on this window. So I think my problem before was just that I didn't actually click in this window. It's like I was typing down there. So cool, there they both go up. See if you can do all the other directions. I'll go ahead and knock it out as well, but if you want to, pause the video and see if you can do it without me. So there's up, down, left, and right are all coming. So down, left, and right. Then the octopus's equivalent of down is S, the equivalent of left is A, and the equivalent of right is D. Very common in computer games for WASD to kind of serve as a up, down, left, right keys. And of course, for down, we want to go -10. For left, we want to go in the X. So we change all these Y's to X's for the left and the right. And you will probably begin to notice the lagginess as soon as we get this code written. And then left is negative. So actually, in a way, our Python code is farther along now than what our Scratch code is, because we've actually got the octopus in here as well. So, oops, I got to click in this window. Up, left, right, down. And you'll notice the lagginess, and it's a little dependent upon your computer. One way to fight lagginess is to increase how fast it moves, but I'll also say that the best way to fight lagginess is to run locally on your computer. Okay, I think we're ready to write some more Scratch code. So the big thing that needs to happen is when you touch the fish, it needs to increment variables and then also move the fish. So let's go ahead and do a couple of those things in Scratch first, and then we'll improve Python as well. So for variables, we'll go ahead and make a variable for the shark score. And whenever you make a variable, you've got to kind of like declare it. You've got to set its initial value, so we'll set the shark score to 0 initially. Then you've got to increment it somewhere, and so we'll go ahead and come in here and we'll say if, and then sensing. So if we're touching the fish, then we want to change the shark score by 1. And so if we were to run it right now, as soon as we get on the fish, it's just going to count super fast, right? So I'm touching the fish and it just goes insane, right? All right, so that's fun, but not the goal. So what we want to do is we want to tell the fish to move, right? So I'm going to broadcast a new message. We'll just call this message move the fish. You can put spaces in here, it's fine. I'll just go ahead and put spaces in here. And then, of course, the fish needs to listen for that. So whenever he receives move the fish, he needs to go to a new random position. You could be careful about the random position he goes to and make sure that it's not like on someone else, but we're just trying to keep it simple here. And so as it goes up, it increments the shark score. You can see I'm at 9, then there I'm at 10, and of course nothing happened at 11. So let's go ahead and see if we can make something happen when we get to 10, and then we'll go catch up Python a little bit. And so if, and again I go blazingly fast, but that's because you have a pause button, right? If the shark score is 10, so if we're touching the fish, we do that. If the shark score is 10, we're going to say shark wins. Shark wins. We'll say it for 2 seconds, and then after that we will end the game. So I'm going to test to make sure that works. So 2, 3, 4. It's nice and smooth in here, which is nice. 7, 8, 9. Yeah, there you go. It says shark wins, and then the game ends. So pretty happy with the game here. I guess we could just go ahead and finish it in Scratch. So if I were to copy this all to the Octopus, the only things that have to change for the Octopus is we have to have an Octopus score, of course. So we'll make a variable called Octopus score. We'll put it right up here, and then of course he needs to change the Octopus score to that. He needs to, his go-to XY is different, so we need to bring that in. So I just kind of like cannibalize the other one. And then of course he moves with WASD. So W is up, down is S. By the way, I should have said this, but some computers have trouble in Python with up, down, left, and right keys. If that happens, just use like JKLI instead of the up, down, left, right keys. Hopefully that won't happen to you, but I have found that when working with somebody. So anyway, the Octopus is WASD. So let's go ahead and run it and make sure I did that right. So up is W, down is S, left is A, and then right is D. So WASD should move the Octopus. You can see that the Octopus is scoring for the shark. I guess we ought to finish fixing this code. So here we want to check for the Octopus score. It increments by 1. And then of course here we want to check to see if the Octopus score is 10. Then we'll say Octopus wins. Cool. I think we've actually just finished the Scratch game. I didn't add sounds because Python doesn't do sounds right now, but we'll fix that someday. But all right, so I'm going to make the Octopus win here. This should be and then so the shark can also get them. By the way, sometimes it shows up right on somebody, but that's okay. So that should be an Octopus win. So Octopus wins. Cool. I think that my Scratch game is done. I'll go ahead and kind of put the code up here. This was the code for the Octopus. Seeing there his complete code is. Here's the code for the shark. And then the pretty simple code for the fish. And so this is the game that we're porting into Scratch, or Python. So let's go into Python now and pick up where we left off. So in Python, we've got movement, and this is what I was saying. If you have problems with up, some people have had issues with that. You can use up or I, and then for down, people can use the down key or K, and then for left, you can use J, and then for right, you can use L. So I don't really care if you put those in, but some people's keyboards, the number pad doesn't work, right? And so this should fix it with this I, J, K, L. Cool, looks like mine's having problems stopping maybe all. Here's what I do. I copy all the code to my clipboard, and I refresh the page. And then that copy to my clipboard makes sure I don't lose anything. Looks like I didn't lose anything anyway. And then usually it goes better after a page refresh, right? So that happens to me sometimes. The only problem with the page refresh is now I've got to kind of relay out my page. All right, so my shark moves but does nothing when I get on the fish. And then I should also be able to move the shark with this J, L, K, and I, and that's just a backup, right? All right, so let's go ahead and do some more stuff with the game. Let's go ahead and start keeping track of scores. So I want to make a shark score. I'll set him to 0. And an octopus score. Set him to 0. One of the easiest ways to make variables is to stick them on one of these objects that already exist, which is kind of nice. And so let's go ahead and say if shark is touching fish. So if the shark is touching the fish, I'll go ahead and make this just a little bigger here. How do I make it bigger? I guess I can zoom in just a scooch. So if the shark is touching the fish, then we want to say shark score is equal to the shark score plus 1. And then we probably ought to update the message on the screen. So we'll say message.words. Let's go ahead and do this. Let's go ahead and copy what we did up here. But instead of always putting in 0, 0, let's use this formatted print string, so an F in front of it. By the way, these quotes, they can be doubles or singles. It doesn't matter. I switch back and forth sometimes, which is unfortunate. Shark score. And then over here, we'll put in the octopus score. My zoom in worked out badly for me there. Cool. And so if he's touching the fish, we'll do that. And then very similar for the octopus. So if the octopus is touching the fish, then the octopus score goes up, and then the message looks like that. So if we were to run it now, okay, zoom out a little. All right, so make sure that you put focus on this window. So I got to click in there, and then I can go up. And now, as soon as I touch this fish, it's going to kind of go crazy with scores there. So I got a 23 with the shark, and it actually like displayed it. And then as I sit there with the octopus, you can see that he goes crazy as well. So that's working really well. The next thing we want to do is we want to move the fish. Now, to be honest, we could write the code for move the fish in both of these places, but you'll notice that these two lines are already identical. So what you want to do in situations like this is you want to have a function called move the fish. And so we'll just call this function in both places. This is how functions work. And then you can write code in only one spot, and that gets used everywhere. So we're going to make a function, move the fish, and then the code in here is going to run when it's called here or there. And you'll notice I'm going to do something sneaky. I'm actually going to take this line of code out of both places. I did a Control X there, and I'm going to move it into the function with an appropriate number of indents. It only needs 2 indents there. But this is nice because they both did the same thing, so now it's in a function. And then the thing that the fish wants to do is he wants to go to, and he wants to go to a random position. I think there's a trick for this. I think, did the airplane do this? I think there's a thing called like random position. Let's go check to see if that's right. So I tried it. I guess we could run it to see if it's right as well. But the way APIs really work is you don't memorize them. You go get good at finding the documentation. So when I touch the fish, I guessed right. I'm going to show you the documentation anyway. This is called the Replit Play library. So I just searched for Replit Play. And then inside here, this is where you learn all the different things that Replit Play can do. So that's where go to, I bet they even have an example, yeah. So yeah, the very first example they did, there was a go to play.random position. So that's how I knew that method existed. Cool. And so now as I hit the fish, he moves and the shark gets a point. Again, it's entirely possible for it to show up right on somebody. That's a feature, and that's no big deal. And you can see that nothing happens when I get to 10. It just keeps right on chugging away. So let's go ahead and check for being at 10. And so you can put this code inside move the fish if you wanted, or you could stick it down here. It doesn't really matter. We'll just say if the shark score is 10. Zoom in a little bit again, then I'll zoom back out later. Remember, the way you do tests for equality in Python is equals equals, because single equals is assignment. So this is a test for equality. If this happens, we'll just go ahead and say message.words, shark wins. And then we would kind of like for the game to stop at this point. If we look at what we did in Airplane, we can see that we did this. We added a game is over variable to somebody. And then at the top of the loop, we check for game is over. And we'll do that same trick again. So we got to decide where do we want to put this game is over variable, like who wants to kind of like hold it for us. It could be on the shark, it could be in the octopus, it could be on the fish. I'm going to put it on the background just because it doesn't matter. Is game over false? So I'm going to make this variable is game over false, and then I'm going to check it at the very top of the loop. And so if background is game over, so if the game is over, then return. And what that does is that says don't run anything else in this loop, and it'll have the appearance as though the game is stopped, right? And so what I have to do here is I just have to say shark wins, and then I'll say background is game over true. I'll zoom out again so you can see all the code. And so this style of initializing the variable, modifying the variable somewhere, and then using the variable follows the pattern that we've seen. So if I go ahead and copy this, this is going to be for the octopus as well. So if the octopus score is 10, then it's going to say octopus wins, and then do game over for him as well. Cool, let's go ahead and see what we've got. There's a chance that that's done, right? We've got to click in here. So the octopus is at, the shark is at 1. Takes forever because of the lag. You could increase the speed from 10 of the shark to something higher if you want it to be more fun. But again, the real way to fix it is to not run it on REPL, right? There it says shark wins, and it kind of locks up, which is great. Let's try the octopus, so be a good tester here. Oops, got to click in this window, and then I can move the octopus. Bing, bing. Is it as fun for you as it is for me? Oh, I got some quick ones there to watch me count to 10. Play your own game, see if your own game works. 9, and last but not least, 10. Octopus wins. Great. We have a finished game, and again, if you were to run it, on your local computer, you would see just how much smoother it is, and that it runs pretty well. So it has nothing to do with Python, the fact that it's all laggy. It has entirely to do with running it locally or not. I'm going to have the octopus win here. Oh, actually, it's shark one. Cool. And so the goal of this is, I know that you're not quite at the point where you could just sit down and write this, but my hope is that you'll learn some about this Play API, and you'll think about ways that you can make changes to your own code. And then you could try some new things. But we learned about the key presses for movement, which is a very common skill you've learned about in Scratch before. The is touching, like sensing, and then also like using variables. And then admittedly, we've got kind of this hacky way to stop the game. Maybe the API will sometime add a stop all command, and you'll be able to use it. All right, thanks for joining us for the Python week. There's a lot of really, really useful skills that you can apply to coding later in your life. But we wanted to have a little bit of fun and to try to get you started with this Replit Play library because it's a good way to introduce you to Python. And there'll be a lot more that you can do with Python later in your coding career. Hopefully you've enjoyed the camp. We did a lot of fun things with Python. We kind of did the guess my number, the syntax guide, and then of course we went through the 3 different ports of Scratch games into Python games, finishing here with Speed Grab. All right, keep up the Python fun. Thanks for joining us in the camp. We hope you enjoyed it. If you had problems, feel free to reach out to us and we'll try to help you out. All right, bye.